Okay, so hello everyone, good morning. Today, this with me Rafa Nariyama from Telsi, and also we have.
Ken from Telsi, of course.
Okay, and today, what are we going to do, Ken?
We are going to explain about binomial distribution and geometric distribution.
Exactly, guys. So before we start, let me explain first the use of binomial distribution and also geometric distribution in solving the mathematical problem. So we use the binomial distribution in order to find the discrete probabilities. Binomial distribution formula helps us to check the probability of getting X successes in N or independent trials of a binomial experiment. And for the geometric distribution, it is likely good of a success given a limited number of trials, everyone. That's all we know, yeah, Ken. So without further ado, let us just move to the presentation when we are going to do the question example. That
Mhm.
can.
Right.
So okay, everyone.
Okay, hello and good morning, everyone. Today we have our first binomial distribution question. So here it is. The Indonesian Ministry of Defense has set a procurement budget to buy brand new military equipment in the Indo Defense 2022 exhibition. In the event, there are 0.45 probabilities of Indonesia buying fifth generation aircraft, 0.42 of buying new tanks, 0.92 of buying drones, and zero point 0.5 of buying a license from Swiss to adopt and produce Swiss-made firearms in Indonesia. The first question is, find the probability that the Ministry of Defense will approve and buy all products in the exhibition, and find probability that out of 6 Ministry of Defense representatives, more than 4 are interested in buying drones. Okay, everyone, in order to solve question number 1, all we have to do is only multiply all of the data given. First, we have 0.45 for the probability of aircraft, 0.42 for tanks, 0.92 for drones, and zero point 0.5 for the gun license. All we need to do in here is only multiply all of the data. So 0.45 times 0.92 times 0.42, and last but not least 0.5, and the result will be shown 0.08694. So there you go. The second question will be a little bit more complex than the first one. Before we solve the second one, we need to identify first the N, or the total intake. We need to identify the P, the probability of success, the Q, the probability of fail, and last but not least the R, or the number of success that we want to find. For the N, we know that there are 6 Ministry of Defense representative, and the question, we are more focused into the buying drones, right? For the question, so the drones, we have identified the drone is 0.92. If the 0.92 is the probability of success, then the Q is the probability of the failure. So the failure will be 0.08. And how about the R? For the R, we need to find out too, because in here the question we're asking is there is total 6 Ministry of Defense, but more than 4 is interested in buying the drones. More than 4, it means 5 and 6. So for the R, we have 5 and 6. So without further ado, we just input all into the formula of the binomial distribution: NCR times P to the power of R times Q to the power of N minus R. So So that means it's 6c5 times 0.92 to the power of 5 times 0.08 to the power of 1, and so on. And the next one will be plus 6c6 0692 to the power of 6 times 0.08 to the power of 0, since 6 minus 6 is 0. Because we were asked to find the probability more than 4 interested to buying the drones, so we only need to find the 5 and 6. To find that, we need to minus 1, because 1 is the total, so 1 minus this one and this one. The result will be shown as 0.316 plus 0.606. 1 minus, if we sum this up, it will be resulting this, and the final result will be 0.078. So there you go, everyone. This is the final answer for number 1 and number 2.
Thank you, Rafa, for the question. Now it is my turn to give you a question about geometric distribution. I've presented you a question about geometric distribution in a case study of random number generator. So what is a random number generator? Random number generator is an application or a system which generate a certain type of number randomly. This is one of the examples of random number generator. Okay, so we got a case study. Suppose a random number generator programmed by Kenn generates random numbers starting from 1 is repeatedly run. The random number generator will only generate one number at a time. Now the question is, what is the probability of Kenn getting the number 3 and below? Now, in order for us to able to solve this question, we need to know the n, the r, the p, and the q. Now, how can we find n? It says in the question that it will only start from 1 and it will only generate one number at a time, which means it will not choose the number 10 and above. So it will be number 1, 2, 3, 4, 5, 6, 7, 8, and 9. So there are total 9 numbers in the n, and therefore we can conclude that the n is 9. Now, what is the R? The R is 3 because it says that the probability of getting the number 3 and below. So it will be 3, 2, and 1. So the total number is 3, which is our R. The P is the probability of success, which is 3 over 9. And therefore, we can also conclude that the Q is 6 over 9 because Q is 1 minus P. Okay guys, so the answer is we need to put in the formula. The formula is P of X equals less or equal than R is 1 minus Q raised by R, which will lead us if we insert the numbers is P equals to X less or equal than R than 3 is 1 minus Q raised by 3, which when we insert the Q is 1 minus 0.667 raised by 3, and therefore it will lead us to 1 minus 0.297, and therefore leading us to the final answer, which is 0.703. Okay guys, that is the end of our binomial and geometric distribution explanation. This is me and Rafa signing off. Goodbye.
Goodbye, everyone. Thank you for your attention.